Hello, math learners! Our lesson for today is applications of exponential functions. The learning objectives are you are going to apply exponential equations or functions in real-life situations and solve problems involving exponential functions. This is the Learning Pocket concept map, and we are going to focus only on the applications. Exponential equations can be applied to describe an increase or decrease in an amount of money, growth or decline of populations, and decay of radioactive elements. In this section, we will examine all of these applications. Let us have examples. Problem number 1 is about continuous growth. Continuous growth occurs continually at each instant. It is used if the number of growth periods are large. Continuous compounding's formula. If P amount is invested at a rate of interest R compounded continuously, then after T years, the investment is worth A is equal to PE raised to RT. So this is the formula where A is the accrued or owed amount or compound amount. P is the principal invested. E or the base E is constant, equivalent to 2.718281828. R is the rate of interest and T is the number of years. Let us have a problem involving continuous growth. If 5,000 is invested at 9% interest compounded continuously, what is the investment worth after 8 years? The solutions: you have to identify the given. P is equivalent to 5,000 pesos. R or the rate is 9%. And change 9% into decimal form, which is equivalent to 0.09. And T is equivalent to 8 years. You have to use the formula. And the formula is A is equal to PE raised to exponent RT. And then substitute the given. So we have A is equal to 5,000 for P, and then copy E. R is 0.09, T is 8. And then simplify. So the exponent now becomes 0.72. And then convert E, and then simplify afterwards. So you copy 5,000, E is equivalent to 2.718281828 raised to exponent 0.72. And then multiply this. This is the result when you raise E to 0.72. So the result is 10,272.16605. So all you have to do is to round off to 2 decimal places, then you will have 10,272.17 pesos. Meaning the investment will reach 10,272.17 pesos after 8 years. To get the value of E using your calculator, So, if the model of your calculator is Casio FX991ES, all you have to do is to press alpha, then press 10 with exponent x, then equals, and then it will give you the value of E. Next problem, about periodic growth. Periodic growth occurs at discrete interval, such as yearly, quarterly, monthly, and so on. Periodic compounding formula for an original amount P growing at an annual rate R with periodic compound N times a year for T years. The formula is A is equal to P times the quantity 1 plus R over N raised to exponent N times T, where A is the accrued or the owed amount or the compound amount. P is the principal invested. R is the annual rate of interest. N is the number of compounding periods or conversion period per year. And T is equal to the number of years. So let us have problem number 2. Suppose that 12,700 pesos is invested at an interest rate of 8% compounded quarterly. Find the amount of principal after 6 years. Solutions. Given P or the principal amount is 12,700 pesos. The rate of interest is 8% or convert it to decimal 0.08. N is 4 because it is compounded quarterly. And T is equal to 6 years. So first, you have to use the formula. The formula is P times the quantity 1 plus R over N raised to exponent N times T. Then substitute the given. So we have 12,700. 1 is constant plus 0.08 over 4 raised to 4 times 6. Divide 0.08 over 4 and you will have 0.02. Multiply 4 and 6, you will have 24. Multiply 12,700 with 1.608437249. And then the result is 20,427.15. So all you have to do is to round off the answer to 2 decimal places. So the amount after 6 years will reach 20,427 pesos. Take note, 1 quarter is equivalent to 4 months. That is why we have N is equal to 4. And then just round off your final answer to 2 decimal places only. Do you have questions? If there is none, let's proceed. Problem number 3. About the exponential growth. Exponential growth is a specific way that a quantity may increase over time. Exponential growth formula for an original population P growing continuously at a rate R for a time T is A is equal to P E raised to exponent R T, where A is the estimated population after T years. P is the original population. E is equal to 2.7182818 the rate is represented by R, and T, the number of years. Let us have now the problem about exponential growth. The population of a small island is growing continuously at a rate of 2% per year. Estimate to the nearest 1,000 the population of the island after 20 years. Given that the population now is 70,000. Solutions. Identify first the given P is 70,000. Rate is 2%. T is equal to 20 years. So use the formula, and the formula is A is equal to PE raised to exponent RT. Substitute the given, so you have 70,000 E raised to exponent 0.02 times 20. And then simplify the exponent, it will become 0.40. And then convert E, then simplify later. So A is equal to 2.7182881828 raised to exponent 0.40. So this part now becomes 1.49182468. And then multiply this part, and you will have 104,427.73. Estimate to the nearest 1,000. So you will have 104,000. At the end of 20 years, the population will be approximately 104,000. Let us have problem about exponential decay. An exponential decay occurs when a population decreases at a consistent rate over time. The exponential decay formula, we have A is equal to P times the quantity 1 minus R raised to exponent T, where A is the future population, P is the present population, R is the rate of decay, and T is the number of years. So the problem is, over the past few years, the number of students enrolled at a certain school has been decreasing. Each year, there is a 12% decrease in student enrollment. Currently, 14,286 students are enrolled. If this trend continues, how many students will be enrolled in 5 years? Solutions. Enumerate the given. So you have P is equal to 14,286. R is 12%, which is equivalent to 0.12. You have to use the formula, and the formula is A is equal to P times the quantity 1 minus R raised to T. Then substitute the given. We have now 14,286 times the quantity 1 minus 0.12 raised to exponent 5. Then simplify. So what we have, 1 minus 0.12 is equivalent to 0.88. Then raised to exponent 5. Then simplify this part, you will have 0.5277319,168. Then multiply. What we will have is 7,539.70. Then round off to the nearest whole number because we are talking about the number of students. So what we have is 7,539. So in 5 years, there will be 7,539 students only. Take note again, You have to round off the answer to the nearest whole number since the problem deals with the number of students. Let us have problem number 5 about the radioactive decay. Radioactive decay, also known as nuclear decay or radioactivity or nuclear disintegration, is the process by which an unstable atomic nucleus loses energy by radiation. A material containing unstable nuclei is considered radioactive. Half-life is defined as the time it takes for 1/2 of the atoms of the radioactive material to disintegrate. And the formula for radioactive decay is A is equal to P times 1/2 raised to exponent T over H, where P is the original amount of radioactive substance, A is the final amount, H is the half-life of the substance, and T is time. So let us have now the problem. The half-life of carbon-14 is about 5,730 years. If a fossil contains 64 grams of carbon-14 and time T is equal to 0, how much carbon-14 remains at time T equals to 17,190 years. Solutions. Given P is equal to 64, H is 5,730, T is 17,190 years. Use the formula, and the formula is A is equal to P times 1/2 raised to exponent T over H. And substitute, we have 64 for P, then copy 1/2, T is 17,190 over H, which is 5,730. Simplify the exponent by dividing 17,190 and 5,730, which is equivalent to 3. Then you can change 1/2 to 0.5. And then simplify 0.5 with exponent 3. So what we have is 0.125. And then multiply 64 and 0.125. So the answer is 8. Approximately, there are 8 grams of substance remains in 17,190 years. Next problem is about bacterial culture. Bacterial culture is the growing of microorganisms on a culture medium in an incubator kept at body temperature for purposes of identification. Bacterial culture formula: the number of bacteria present in T hours is found by the formula A is equal to P times 2 raised to exponent T. P is equal to the original amount of bacteria, A is equal to the bacteria population after T hour, and T is time. So let us have the problem now. If the number of bacteria in a certain culture double every hour, and there are 250 bacteria present initially, find the approximate number of bacteria present after 20 minutes. Solutions. The given P is equal to 250, T is 20 minutes or 1/3 hour. So we have to use the formula P is equal to P times 2 raised to T, and substitute the given. So what we have is 250 times 2 raised to exponent 1/3, and then simplify. So what we have is 250 times 1.25992105. Then multiply this. So what we have is 314.98. Then round off this to the nearest whole number. So what we have is 315. So after 20 minutes, there will be approximately 315 bacteria. Do you have questions? If there is none, then see you next time. Bye!